Hi everybody. So if you've been following my series on soil moisture monitoring, you'll know that I recently added a second shielded temperature pressure sensor, or a BMP280, to my original BME280 to help me eliminate bias resulting from a poorly designed radiation shield. Both sensors in my deployment are the generic breakouts you can purchase on eBay for a few dollars, but rely on the open source Adafruit BME and BMP sensor libraries to drive them. These are specifically designed for Adafruit's hardware. I appreciate and support Adafruit with purchases that help with the development of their open source libraries, but I also like to explore cheaper alternatives on eBay for those who can't afford the markup. In this case, integrating hardware not sold by Adafruit with libraries specifically designed for their hardware led me down a rabbit hole of incorrectly assigned and conflicting I2C addresses when trying to get my sketches to work. In other words, I was getting messages like this when trying to drive variants of the BME280 or BMP280 sensors using Adafruit's sensor libraries. In reviewing online forums for a remedy, I realized this is a common issue, so in this video I'll summarize what I learned in successfully getting my generic breakouts purchased on eBay to work together nicely with Adafruit sensor libraries, and also how to add two of these generic sensors to the same I2C bus without having to purchase a multiplexer. So backing up, we're all familiar with the detailed tutorials and open source libraries Adafruit develops for its hardware and its customers. In regards to the BME280 sensor, the sensor test example that Adafruit includes with its BME280 library clearly states that it's designed specifically to work with the Adafruit BME280 breakout, which, by the way, has a default I2C address to be 0x77. If you review the header file for Adafruit's BME280 sensor library, you can see the address is defined accordingly to work with its own specific breakouts. Wiring the BME280 provided by Adafruit using I2C protocol is trivial, and you should have no trouble getting the sensor to work with Adafruit's library and example code. This is what makes purchasing hardware on Adafruit well worth the markup, since, after all, you're getting quality and clearly explained guidance and support, which isn't the case for the hardware purchased on eBay. Things can get a little tricky though if you're trying to use the same sketch to drive a BME280 purchased from another party, since the hardware address for these breakouts is defined as 0x76, rather than the default 0x77 mapped in Adafruit's hardware. This means that if you start the sensor in your code using Adafruit's library, it's going to default to the 0x77 address when searching for the sensor, which in turn will lead to a warning like this, asking you to check your wiring or I2C address mapping. If you're like me and not well versed in I2C, messages like this can be a little intimidating. In regards to the BME280, fixing this is easy enough by defining the correct I2C address in code when using the sensor test example provided with the Adafruit BME280 sensor library. I'll demonstrate what happens before and after you make this change next. The same can be said about the BMP280, for which Adafruit also provides a library that also defaults to an I2C address of 0x77. As with the BME280, the address of this sensor purchased on eBay defaults to 0x76, which will throw an exception. Unless, as with the BME280, you define the address explicitly in the example code shared with the Adafruit BMP280 sensor library. Now, what if you want to run two BMP280s at the same time? Both will default to an address of 0x76 in hardware, so in this case, you can pull the pin labeled SDO on one of the sensors high, which will set its address to 0x77. Now you can start two BMP objects using their respective addresses in code, thus avoiding the address conflicts. Next, what about if you want to run two BME280s on the same I2C bus? To change the address in hardware for these sensors, you need to work with these three pads, shown in the breakout that's highlighted on the right. To set the address to 0x77 on one of the two BME280s, cut this trace and solder these two pads together. This respective BME280 will now have an I2C address of 0x77. And again, you can start both instances of the BME280 by calling their addresses explicitly. In regards to the BME280, beware if you have one of these variants that have the three smaller pads with solder on them. Your results might vary, but I've had little luck in cutting the trace between the first two pads. There's no trace on the surface of the PCB to cut, and digging deep under the surface doesn't seem to help. So I wouldn't recommend using this variant if you need to change the address in hardware for the respective sensor. Now, if you're just going to go ahead and use one sensor, there's no problem in using this breakout. Finally, if you want to combine the BME280 and BMP280 on the same bus, the easy thing to do is define the address for the BMP280 as 0x77 by pulling the SDO pin high, as I demonstrated on a prior slide. And of course, once you have your hardware mapped properly, you'll want to then define the addresses explicitly in code as shown here. And of course, if combining a BMP280 with an Adafruit BME280, just accept the default I2C hardware addresses, and then define accordingly in code. Now, what if you want to add more than two sensors to your setup? In this case, you can purchase this I2C multiplexer from Adafruit, which will let you add up to 8 sensors with the same I2C address on the same bus. I haven't tried this option since modifying code alone was enough in my case, but it's an inexpensive option if you want to explore it. So that's about it for this chapter. In my next chapter, I'll give you an update on upgrades to our soil moisture monitoring experiment. Thanks for watching, subscribe for updates, and we'll catch you next time.